Okay, so back to our regular series of webinars. Last week Georgia was presenting the last one, doing a great job, of course. I'm Stefanos, one of the founders of Phenometry, and today we're going to talk a little bit about dimensioning and precision. So various tools that Phi includes that can help you design your models with more precision, with exactness, with geometric requirements, because we talk a lot about this push and pull way of designing, which is great and very fast, but very often we know that users need to be quite strict about dimensions and other engineering constraints. So that's for today. And as always, you can interrupt me, ask anything in the chat, or I try to leave a little time at the end of the webinar. And here we go. So let me switch to good old Onshape. I always like to run Phi from within Onshape, the Onshape environment. You can also run it standalone, as you know. So here we are inside Onshape. Phi is running in a tab at the bottom of the screen, and we're about to get started. So the first thing I'd like to mention about dimensioning is that, for instance, if you select any of these default objects that we offer to get you started, you will see right away that you can give specific dimensions to it. So let me call this, I don't know, I'll call it cube. And I can have a cube that is 2 by 2 by 2 centimeters, for example. And it comes in exactly with that dimension. As I'm sure you have noticed, if I click on two vertices, any two vertices, I get here at the bottom right an indication of the distance between them. That's just a quick way of checking dimensions. Now, the fastest way in which you can modify the dimensions of one of these three objects that you work with is to select either two vertices or one edge and then hit the D button. D stands for distance. And this little menu comes up and it gives you a few options. So first of all, we're going to work with the distance between the two selected vertices. If you noticed, I selected an edge actually, but the edge effectively corresponds to its two end vertices, so these become selected. So initial distance between the two vertices is 2 centimeters. So I can just make it, like, I don't know, 2.3. And the options I have now are, first of all, in changing this distance, so in moving the two vertices apart to a distance of 2.3, either the entire body can scale with the two vertices, move all together and scale globally, or only the two vertices will move. So in this case I have selected scale the entire body. So you see the entire body scaled to adapt to the new distance between the two vertices. Now if I repeat this and I uncheck this button, sorry, what have I done? Let me try again. Yeah, I didn't give a distance. Yeah, okay. So if I uncheck this button, you see only the two vertices moved. So the body deformed. It's no longer a cube now because only my two vertices moved and not the entire body. So let me go back here and select this again. And the second option I can select is to scale the entire body proportionately. So before you noticed when I scaled the entire body, it moved only vertically because the two vertices that I selected are one above the other along the Z direction. So now if I hit scale proportionately, the entire body inflates or deflates, transformation in all directions to accommodate the requested distance. And my last option, if I do again, I don't know, 2.5, is I can select the first vertex that I selected. So in this case, the one vertex is locked, the first one I selected, and only the other one moves. So these are the options I have in using this scale menu. Okay, now That's, let's say, the quick way of dimensioning or scaling a body. There's also a scale menu here at the top of the functionality buttons. So this gives us a little more flexibility. For example, I will select the entire body and I will hit scale. Now, here you see that I have the option of scaling either the entire body proportionately by setting this distance here. We represent it with a diagonal, meaning the whole thing will inflate, or I can scale only along one of the directions. So I can scale 120% along the X direction, for example, and let me make this a little, yeah, that was a little bit on the way, sorry. And as you see, the scaling happened as requested. Now, another thing I can do is I can actually, let me redo this, because I had this little checkbox here checked, so the model rescaled proportionately, whereas in reality, sorry, let me go in because I'm doing things the wrong order. So I have unchecked rescale proportionately, and I ask for 120 along the X direction. So this is what you see. Fine, this is actually pretty much like what we were doing before. But I can do something else. I can select again the entire body and any two vertices. And now the scale menu gives me not only a proportional change option, but also a distance change. So for example, I can ask for the Z direction to become 2.5, like we did before. So this is quite similar to what I was showing before. However, one main difference is that what we did before with the quick scale, the D button, with this menu here, affects the entire body. Whereas in this menu, we can work with only a part of a body. For example, let me try this little pop out here and scale here. And then I can select only this part of the body. And I can hit the scale, and then I can do a scale along the X direction. And as you see, only this part of the body was scaled, the rest remained unchanged. So let me try this again. I will select the same part, and now I will also lock, I will select this single vertex here, and I go to the scale menu, I hit the lock first selected vertex, and I scale along, I'll do a proportionate scale here, 150%. So you see the scale happened on this part of the body, and the rest did not move, and the edges that connect the scaled with the rest of the body had to deform, obviously, to allow this operation to conclude. And given that this vertex here was locked, you see that this edge remains linear. I didn't move at all, whereas the other three edges had to deform to, let's say, accommodate for the scaling. So if I undo, you see what happened over there. Okay, so that's the scale menu. Now, another thing I can do that has to do with coordinates and precision is that if I shift click on any vertex, I get this little pop-up window that shows me the coordinates of this vertex in 3D space, and I can go in and edit them. So I change from 1 to 1.2, and this vertex moved. So that's a direct way of positioning any vertex within 3D space. And if I display my axis, it becomes a lot more easy to see in which direction we want to move. By the way, we noticed before when we shift click on the vertex that I can give coordinates like that, and if I shift click again, I see the coordinates with, in this case, just one decimal place. But in the settings menu, I can define how many decimal places I want to be using. So in this case, if I go up to many more decimal places and I shift click on the vertex, I get a display which is truncated only to so many decimal places. So this helps make the interface a little cleaner when we want. Okay, that was just a detail. Now, another thing that you can use is our grid. So with this button here, you can display a grid around the object you're working on in 3D space, and with the button above it you can specify the density of the grid, so how many grid lines, the spacing between the grid lines. And once you have a grid, you can move around, and the grid rotates. It's actually placed in 3D space, and it becomes gray. But when you click to rotate down the X, Y, or Z coordinate, the X, Y, or Z actually axis as your view direction, the grid turns either green or red or blue. Now, this means that now the grid actually becomes active. So it's not only for display, but now if you, for example, grab a vertex and move it, it will snap to the grid crosses, the places where the grid lines form a cross. And so you can position with precision the vertices of your model. And not only that, but if you bring up the move manipulator, this will also snap onto grid onto the grid. What have I done now? It's not. I think I'm having a little bit selecting here. I see what's happening. Okay, let me try this again. So I selected the entire body, and the move manipulator appeared in the middle of the body on the grid, so it was a little hard to grab. But I can do this. I will select my body, and then I will show my vertices, and I will select just one vertex. And now my move manipulator will appear on this vertex. And let me repeat this. Select the body, show vertices, select a vertex, M. And now if I zoom in, yes, what I was doing, I was trying to pull from this little box here, which is the free drag, whereas this plane is the drag that we use within the plane of view. So now, as you see, I'm dragging the manipulator, and it's always snapping onto my grid. So for example, if I wanted to, let's say, make sure that this vertex of my body is positioned exactly there, I would select everything, then I would select additionally this vertex, I would bring up the manipulator, and now I can position it exactly on my grid, this vertex here. So that's a use. And one other thing I wanted to mention is that when you have your manipulator showing and the grid also displayed, like for example here, apart from the translation, which snaps onto grid points, as you see, we also make the rotation happen in angles, in steps of 30-degree angles. So here you see there's not a continuous rotation, we go 30 degrees at a time. If I hide the grid and bring up the manipulator again, now we have a free rotate. So effectively we use the existence of a grid as an indication that we would like to rotate in steps and not continuously. Right, so this is how you can use the grid. And by the way, if you rotate out of the orthogonal view, like here we have a diagonal placement, then the grid is no longer active. This is something to remember. So when you're looking in an oblique direction with respect to the grid, or rather it is active, but okay, let me clarify this. It is active, but not in a perpendicular view. So here, imagine rays going through your vertex perpendicular to the screen, so along your view direction, and hitting the grid. And we will position these vertices that move so that the ray that goes through the vertex hits a grid cross. So effectively, if my grid dimension was, for example, 1 millimeter, now that I'm looking at it obliquely, I'm not really snapping at 1 millimeter. I'm snapping at a distance that is shorter, because I'm looking at the dimension of this grid element at an angle. So it's the projection of the grid element onto the screen. So I just wanted to clarify this, so there's no confusion about how the grid works when it is not perpendicular. So basically what we recommend, and actually the reason why we flip the colors every time you hit one of these orthogonal views, is to make sure that you are using the grid exactly as expected. So snapping onto elements of the dimension that you selected in the grid spacing. First, make sure to rotate the view down one of the orthogonal axes, X, Y, or Z. Okay, I'll hide the grid now. And now back to our model. Now, I will mention a few more operations that have an element of preciseness, exactness in them, although these have been covered in past tutorials, but it's okay, it's not bad to do a little reminder. So first of all, you remember that as you hover over any edge, if you hit V for vertex, you get a vertex added at the position where the mouse is currently hovering. But if you are over an edge and you hit Shift V, actually just hitting Shift will show you a gray indication of where the center of the edge is. And then if I hit the V button, I get the vertex, a vertex added there. And if I hit Shift repeatedly, then every time we split the edge in one more number of equal parts. So in this case I have hit the Shift button 3 times, so you see the indication of 3 vertices, and I hit V and all 3 vertices are added. And they are added so that the distance, actually the length of these edges, of these new edge segments that were created by adding the vertices on the original edge, have the same length. So that's a way of ensuring a precise separation of an edge into parts with exactly the same length. It's not the distance between the vertices that is equal, it is the edge length in each one of these segments. And one other operation that is useful, and actually not many users remember, is that if I select a vertex, like this vertex here, actually bring in the coordinate plane also, and then I hover over an edge and I press Shift, then what happens is that the existence of this selected vertex changes the behavior of the Shift key. So instead of showing me the middle of the edge, or if I hit it repeatedly, points on my edge that separate it in parts of the same length, I get an indication, as you see there, of the location on this edge that is exactly across from the selected vertex. And then when I hit V, a vertex is added there. So let me explain what I mean by this. Exactly across means, in this case, that this has the same XY coordinate, actually the same YZ plane with the original vertex that I had selected, but it's further up. So in other words, we select one of the 3 orthogonal planes. We imagine this plane passing through the original vertex and slicing our edge, and we place the new vertex at the location where the edge is sliced. And whether we select the XY or the XZ or the YZ plane depends on the geometry and the placement of our object. And this is useful. Why? Imagine, for example, if I let me flip another dimension. Okay, imagine that okay, let me give this example. I have this. I'll hide the planes. I have this vertex here, and I would like to place a vertex on this edge that's exactly at the same vertical plane, horizontal plane as this vertex. So I go here, I press Shift, I hit V, and now this and this vertex have exactly the same Z component, their coordinate. And if I do the same, select this one for example and hover there, I get another indication. Sorry, I moved my mouse. So this vertex and this vertex and this vertex now all belong in the same horizontal plane. It's a convenient way of separating your edges, which you can then connect, for example, with new edges, and form shapes while the vertices are in the same perpendicular plane or horizontal, depending. Okay, let me see, there's a couple of minutes left today. This is mostly what I wanted to mention, but since I don't see any questions in the chat, let me say one more thing. I would just like to remind you of the existence of the place menu, which we have already discussed. And what this place menu does is, I'll give an example. Let's assume I have this shape here, and I want to bring this vertex at the same vertical level, so move it up to the same plane as these two vertices. Then I can select one of them, or both of them for that matter. I hit the place button, and then I have various options. I can either apply a specific behavior for each one of the three components of the coordinates of these selected vertices. So either I can leave the x, the y, or the z coordinate as it is, not change it, or I can make, for example, the x have a specific value, or in my case I will make the z, I will leave the x and y coordinates as they are, but the z coordinate, the vertical coordinate, I'll make it have the same value as the first selected vertex. So this means that all three vertices will move vertically only, not along the x or y direction, until they reach the same z coordinate. And as you saw what happened, this vertex moved up, and it is at the same coordinate with the other two. So the two first vertices I had selected, these ones here, already had the same z coordinate, so nothing happened there. But this third one moved exactly there. And now, for example, I can make these two edges linear, straight lines. So I have recreated this flat surface at the top of my model by bringing this vertex up as much as it should. Okay. And actually, I think that this is all I wanted to mention about precision and control behavior and coordinates and things like that. So I will just finish by reminding you all, I'll make this also linear, now I'm just messing around really. I will remind you all that Phi is currently running within Onshape, as you know, and we have this very good integration between Phi and Onshape, which means that this little, I don't know, strange shape that I have created, I can send it over to Onshape just with a click. So I hit the Send to Onshape button. I'll give this a name. Well, it's no longer a cube, so I don't know, I'll say strange cylinder. I hit Send to Onshape. So now this model is being transferred from Phi onto our host application right now, Onshape. It will appear in a new tab in a few seconds. There it is. And it has been translated into a perfectly valid Onshape Part Studio. And this is exactly the shape we had in Phi, but now you have it in Onshape, and you can do whatever you want with this. You can add it to your assemblies, you can do Boolean operations and things like that. So I just wanted to stress this communication that we have between Phi and Onshape that makes the designer's life a lot easier. So that's it for today. I think I'm almost out of time. Sorry for the shaky start. I was just getting my bearings again and remembering how to use the streaming software. It's been a few weeks for me. And so thank you, and see you next week. And please, if you have any models that you would like to share with us, we'd be more than happy to have a look or showcase them, discuss them, or give you any help you want. So until next week, thank you and goodbye.